Welcome. I am Sanne van der Linden. Together with my supervisors Anna and Stef, we present FlexEvent. We are from the Technical University of Eindhoven and we collaborated with Bernice, Merel and Sebastiaan from the Kempenhagen Sleep Medical Center and with Carola from the Maxima Medical Center. On Sunday, the 25th of September, 3 minutes before 12, my cousin got a speeding ticket of €42. But this was not really possible because the 25th of September, 3 minutes before 12, my cousin was playing Beat Sabers on his virtual reality headset. And he did not lend his motorcycle to any of his friends. So he looked into the letter to see what was actually the problem, and he just completely started laughing. Afterwards, he called the government and he told them to take a look at the picture to tell them what was wrong. This was what was actually happening. This is already an example of multivariate event sequence data. First, I will explain to you what it actually is and why it is so important to analyze this type of data. So first, what is multivariate event sequence data? Well, imagine that you have a circle, and this circle represents my cousin. Then you have discrete events in time that are happening to my cousin, the circle, in a particular order. For example, my cousin brought the motorcycle to the shop, then the motorbike was loaded onto the trailer, they went driving with it, then they speeded with it. The ticket was issued by the government, my cousin read the ticket, started laughing about it, then he emailed the government what was wrong, and afterwards he called both the government and the motorbike shop. But now I only described the event based on their activity attribute. But each of these events also have multiple other attributes, such as, for example, their ID or their location or a description. And all of these events are homogeneous. That means that every event has the same set of attributes. And these events are grouped together because they all belong to my cousin. And they are ordered in time to form a sequence. In this situation, my cousin is called a case. But also the case, my cousin, also has some attributes, such as, for example, his name. But different cases are also possible. Now we looked at the perspective from my cousin's point of view, but we can also look at it from the government's point of view. And then the events would change. They would be measuring speed, taking the image, creating the invoice, and etc. All these attributes make it very complex because you have many possible sequences and many possible relationships. And you only have that much space to fit on the screen, but in reality, your data set and your relation space is so much bigger. The second question was, why is it important to analyze this type of data? This example of my cousin is only an example of a low-risk case because it only concerns these €42. But there are also examples of high-risk cases, such as understanding sepsis in prematurely born babies. Sepsis is one of the important causes of death in prematurely born babies, so it is very crucial for doctors to understand what is going on. And this is also an example of multivariate event sequence data. We require a flexible data structure. The input to our visualization method is therefore one big table, where the events are the rows and the column are the attributes. Some of the attributes belong to the case attributes, and other attributes belong to the event attributes. In this project, we assume that the data is homogeneous, so all events have the same set of attributes. We identified based on user interviews that multivariate event sequence hypotheses need 3 perspectives in order to be answered. Imagine that we have a dataset focused around the medication of sepsis patients. We have 4 babies. We have Aaron, we have Brian, we have Carola, and we have Diana. And for each of these 4 babies, we have a sequence of medication events. We need flexible switching between 3 perspectives, the case perspective, the attribute perspective, and the event perspective. For example, the purple medication after the green medication of Brian looks a bit strange based on domain knowledge of users, and they want to analyze this a bit further. So, an event perspective is needed to see which other babies received this purple medication. We can, for example, see that Diana also received this. The next question might be which doctor prescribed this medication. Therefore, we want to change what defines a sequence interactively. We now display the doctor as sequences where each circle represents a doctor. And for each doctor, we display as events which patient they prescribe medication to. We can now see that there is one doctor that prescribed both Brian and Diana the same type of medication. Because we change what a case and what an event is, also what the case and what the event attributes are changes as well. For example, the patient age was a case attribute in the beginning, but now the doctor's age became a case attribute. Next, we might want to find an explanation for why this doctor prescribed this medication. The users can have a hypothesis that it might be because the doctor is a bit older and in the past this medication was used more often. Therefore, we need an attribute perspective. And users can see that the doctor who prescribed the medication is indeed a bit older. What I want to convince you of is that if you have all this multivariate event sequence data, in order to analyze it, we need FlexEvent, an interactive visualization method for multivariate event sequence data. And it has these three perspectives: the case perspective, the attribute perspective, and the event perspective. And we need all of them combined in order to display flexibly and interactively side-by-side visualizations in order to analyze this multivariate event sequence data. State-of-the-art visualization techniques do not address the need to explore this multivariate event sequence data from these multiple perspectives. First, most techniques visualize the event sequences only from a univariate perspective, with row-based visualizations, such as hierarchical visualizations and Sanne flow diagrams. Univariate entails that all the events show the same single attribute next to the case it belongs to, the time and the duration. This means that the analysis of the previous example would stop at the first step. We can see the medication events for the babies, but if we want to see other attributes or see the data from different perspectives, it is not possible. Second, visualizations only present data from a fixed case-centric perspective. This means it is not possible to switch the case from patient to doctor. Third, to circumvent this, most visualizations provide additional visualizations to display case metadata or other event attributes, most often on the side. However, the connection with the events and the cases in the sequences is lost. Often only the distribution or the total event attribute values are shown, and it is not possible to explore the data from event or an attribute-centric perspective. All in all, it is therefore difficult to explore multivariate relationships in a context. To help the users, we examined literature, papers mentioned in related work, and 3 event-related challenges to identify general tasks. Second, we also held interviews with 6 domain experts to confirm these tasks. The 2 most important tasks are the need for having these 3 different perspectives and the ability to derive additional attributes to enrich the data. Users can compute additional user-specified information to discover non-trivial patterns between events or cases. For example, the frequency of uncommon medication, or discover multivariate relationships by computing combined information of multiple attributes. This helps to make sense of the data space with all these possible relationships. Based on user interviews, FlexEvent offers 5 automated methods: grouping, dimensionality reduction, clustering, frequent patterns, and frequency computations. These methods all add derived attributes to the data table as a new column, and then they can be used similarly to all the other attributes. We do not make this distinction between the original and the newly derived attributes. Users can also add their own automated methods for specific use cases. What I want to convince you of is that if we have all this multivariate event sequence data, in order to analyze it, we need FlexEvent, an interactive visualization method for multivariate event sequence data. It has 3 different perspectives: the case perspective, the attribute perspective, and the event perspective. And we need to combine them and display them flexibly and interactively side by side in order to analyze the multivariate event sequence data. FlexEvent consists out of visualization multiples. These multiples are called FlexEvent tiles. The user can add them or remove them or position them flexibly in a grid. First, I will explain one FlexiPlot tile, and then I will explain how they all work together. We will use one of our use cases as a running example. The data is sleep disorder data with around 82,000 events and 25 attributes. These attributes range from patient to sleep data to heart rate. The researchers want to confirm their multivariate hypothesis. Sleep stage and 1 and 2 and awake occur more around REM sleep than N3, and there's no clear relation between the amount of time of REM events and the diagnosis. This is known to be true based on previous sleep research. A tile, you can see 2 here, generalizes all perspectives into a single flexible visualization tile. The tiles are built up upon the concept of a scatter plot. We started from observations that all the existing event visualizations are essentially these scatter plots. In general, events are positioned in a scatter plot-like visualization where they are positioned according to 2 attributes, such as the case identifier and the time. Cases are often implicitly encoded and each event sequence represents a case, but here we make them explicit and introduce a separate linked FlexiPlot tile to show these. The cases are represented by the circles and the events are represented by rectangles. The color represents the value of a selected attribute. This can be a derived attribute representing information between multiple of these attributes. In this case, the color represents different sleep stages. We start by representing a familiar view, a case-centric perspective, showing the sequences with the case attribute on the y-axis and the time on the x-axis, as is the general solution in related work. The left FlexiPlot tile starts with displaying the cases ordered on case identifier, and for the x-axis we pick a constant value, basically to align them vertically. And this provides the users easy access to an attribute-centric perspective later on. Each tile supports common interactions, such as mouse selections, zooming, panning, filtering, etc. Users filtered on young patients and events that happen before REM sleep and the REM sleep itself. We can see that young people have long blocks of REM sleep of multiple short blocks of REM sleep. The users are interested in the long blocks of REM sleep. However, in contrast to traditional event visualizations, we enable users to change both the axes. This opens up the ability to incorporate multivariate data in the exploration process. For example, cases, the patients, can be ordered horizontally according to their age attribute. We change the left plot to an attribute-centric perspective to see if the diagnosis has a relation on these long blocks of REM sleep. Without changing the vertical position, this integrates the multivariate data in the other view. This enables users to explore the data and discover relationships. We see that there is no clear relationship between diagnosis and long blocks of REM sleep, for example. Users are enabled to inspect an event-centric perspective by changing the FlexiPlot tile axis and select whether events or cases are displayed in the plot. The next thing we want to find out is if there are patterns which occur in these sleep stages for each of these patients. Therefore, we change the left plot to an event-centric plot, and we see that there's only one patient that has N3 and unknown sleep stages, and all the other patients have all the other sleep stages. Now I will describe how the tiles work together. We enable users to add or remove additional tiles for a small multiple-like experience by having these tiles arranged in a grid with these flexible axes. To support users in the exploration process and help them with pattern discovery and comparison, some of our tasks for example, we can get more in-depth information such as how often, for example, this occurs. Therefore, we extend our small multiples and add 2 more graphs. Also, we enrich the data by computing the frequency attribute for the current filtered selection, which is one of the automated methods. We can easily use the flexible event scatter plot to change the data to areas of interest. Interactions such as linked y-axis make the analysis process more smooth. We display the total frequency of the sleep stages and the frequency per patient. We would like to compare them to the other plots. Therefore, we change the size of the small multiples. And we can see that mainly N2 and N1 occur around REM sleep, which is in line with research. To continue the search, we can use the mouse selection to select a single N3 sleep event. Using the linked plots, we can see where it occurs elsewhere, and that it is followed by a short REM event and some unknown sleep events. We can also remove the small multiples again and derive a new attribute to compute, for example, the frequent patterns. Each event scatter plot is also flexible in the sense that users can select if cases or events are displayed. One interesting pattern emerges. which is n2 followed by n1 and then 3 times n2. We can see it occurs in 4 of the patients and 2 times before and 2 times after REM. This gives interesting results to continue future explorations and also start relating these sleep patterns to, for example, other attributes to find more information. Interface controls offers users the flexibility to switch between cases and events, but also change within and between perspectives instantaneously. The design choices on the individual and linked FlexiPlot tiles also have the advantage that they are easy to understand, generic, and easily adjustable to provide extra flexibility that the users require. We evaluated FlexEvent in 2 use cases with 3 users. Those show the usefulness of this method by answering the user's hypothesis based on the defined tasks that go beyond the state of the art. All users mentioned that they would like to use FlexEvent in the future based on 3 reasons. First, it would speed up their analysis and interpretation process. Second, the users do not need to reprocess the data every time, which is quite cumbersome, in order to create unlinked views based on different instances. And third, all the data is linked interactively. Further, users completed all the different tasks without any problems. And moreover, users can gain more in-depth insights by looking at the data from these 3 different perspectives. However, users also mentioned they might need some time to get used to FlexEvent, but they were quite confident that they could learn it quickly. There are options for future work tour study. First, we would ideally monitor users using FlexEvent over a longer period of time to identify the added value of FlexEvent in their natural work environment. Second, instead of using homogeneous events, it would also be interesting to look at events with a different set of attributes. Third, if we would have like thousands of sequences and they also can become really large, it's interesting to see how they would fit on the screen. So more of a visual scalability aspect. And fourth, sometimes users do not have an idea where to start their investigation yet, although the frequent patterns and dimensionality reduction can help somewhat to find multivariate relationships. In conclusion, what I want to convince you of is that we have all this multivariate event sequence data, and in order to analyze it, we need 3 perspectives: the case perspective, the attribute perspective, and the event perspective. And we need to combine them and display them flexibly and interactively side by side in order to analyze this data. This is accomplished by using FlexiPlot tiles in a grid with the option to enrich the data using automated methods. With FlexEvent, we can analyze, besides high-risk cases, also these low-risk cases, such as in the end my cousin does not have to pay the €42.